Hey there everybody, and happy Friday. You guys did awesome today. Listen, even Mr. Bones says, you did awesome. So let's go ahead and get rocking and rolling so we can have our little review on what we covered. Let's start over here with our GQ. Today we went over the standard GQ, recognize and explain that authentic scientific investigation frequently does not parallel the steps of the scientific method. SC.5.N.1.5. So if we come over here like we did with the other standard, we broke it down with everybody. We decided that recognize means to see, to know, to understand, and explain, saying something in detail. That authentic, which we said is real, not fake. For example, if I came in and said I had authentic alligator skin boots on my feet, they would be made out of actual alligator skin. Scientific investigation, to find or to try to figure something out or to look for. Frequently, to do often, to do a lot. Does, and here's what's tricky, not parallel the steps of the scientific method. We decided that parallel meant to mirror one another. The lines are going to be congruent. So if it's not parallel, it does not line up. A lot of the kids needed a refresher on what the scientific method was. 1 is to make an observation, 2, ask a question, 3, form a hypothesis or testable explanation, 4, make a prediction based on hypothesis, 5, test that prediction, and 6, use the results to make a new hypothesis. So if we go back over here to our GQ, I'm going to reread it. Recognize and explain that authentic scientific investigation frequently does not parallel the steps of the scientific method. So I used a couple different examples, and kids, you're going to really be able to connect with this one, because if you remember when we did our table building project, we had Lutz in first period end up winning the entire thing because her and Deja made a very intricate design. And if you look inside right here, it's got balls. They balled up paper and they balled up other pieces, and they made it so that there was a center mass of gravity that was good. And the thing is that they thought outside the box. Instead of doing 4 typical table legs, which here's some examples of some other kids doing it. These are not from my school. These are from the engineering design paper that I got from Miss Susan Lopez. This young lady decided to think out of the box. So instead of doing the typical table design, they decided to try something different. They were very good at their engineering. They asked questions, they imagined, they planned, they created, they tested, and they improved their idea. But the whole purpose of this is because we want to know why this is important. This is why. There is no one way to do science. And what they did with that table design is a perfect example. Now, another thing that we decided to bring into this was variables. If you watched the video from yesterday, we did a project where we measured the height that a ball dropped, and we used different surfaces to test our data to see if that affected the height that the ball bounced back up. Now, we talked about that there were different kinds of variables. There are 2 different kinds of variables, our independent or dependent. So our independent variable can be changed or manipulated. So I was super proud of the kids because I said, now tell me something from that project that's independent. They were able to tell me that if I changed the type of ball, the type of surface, the force used to drop the ball, or the height that the ball was dropped from, it's going to manipulate and become an independent variable for my project. A dependent variable is the outcome variable. So that's what we're actually asking ourselves, what are we testing for? This is measured and stays constant. So the kids were able to determine that the height the ball bounced back up after hitting the surface, we're measuring in inches because we're using a yardstick. That's going to be our dependent. Then they were able to tell me what the control was. The control is going to stay the same. So they were able to tell me that in our project, we used all tennis balls. So the type of ball and the height the ball was dropped from is technically our control in that experiment. They also had the ability to tell me that if we changed the type of ball and used a bowling ball as compared to a tennis ball, that their results and their data would have greatly varied, including the height that the ball was dropped. So our control for that experiment, like I said, was the tennis ball and the height that the ball was dropped from. I'm super proud that they were able to make all of these connections, because I know I have learned it when I can recognize and explain that authentic scientific investigation frequently does not parallel the scientific method. So not only did we do a project that more or less followed the scientific method and had a little bit more rigorous structure to it, but we also took in an engineering design project that we did together that really didn't fit the mold and find those steps that a lot of people have the misconception that are necessary in order to do a scientific project. Because in the end, there is no one way to do science. So everybody, you did an awesome job today. I hope you have an amazing weekend. Have lots of fun. Make sure that if you have any of your friends that want to follow the page that are in our class, you give them the username so they can subscribe, and stay safe this weekend. I look forward to seeing you on Tuesday. Have a great time.